What does it mean for a function to solve an ODE? All this means is if you plug in the function on both sides of the ODE, they should match. And in fact, let's see 3 instances of this. For example, does y equals 3t plus t squared solve the ODE t times y prime equals y plus t squared? Well, let's see what happens when you plug in 3t plus t squared, both on the left-hand side and the right-hand side. So on the left, if you do t times y prime, that becomes t times 3t plus t squared prime, and that becomes t times 3 plus 2t, and that is 3t plus 2t squared. On the right, if you do y plus t squared, well, that gives you 3t plus t squared. That's our y, plus t squared, and that's 3t plus 2t squared. And in fact, see, both sides match. And that's why we say that 3t plus t squared is a solution of the ODE. So both sides match. So yes, that works. But now, or maybe now, let's do the following. So let's check. So does y equals t squared solve y double prime plus ty equals 2? Let's see. So let's plug in t squared on the left-hand side and t squared on the right-hand side and see if it matches. So y double prime plus ty, that becomes t squared double prime plus t times t squared. Derivative of t squared is 2t. If you differentiate it again, you get 2. And that's 2 plus t cubed. But then the right-hand side, there's actually nothing to plug in because it's 2. And notice, sadly, those two things don't match. 2 plus t cubed is not 2. Don't match. So, okay, I do want to say a remark that confuses a lot of students, because notice it does match for a particular value of t, namely t equals 0, but the short answer is we don't care about that. If something solves an ODE, it needs to solve it for all t, or maybe all positive t, or at least an interval. Just because it works for one point doesn't mean it's a solution. Let me write that down. So it matches at t equals 0, but basically we want for all t. Okay. Last but not least, a very cute problem related to that. So let's determine in this case for which r y equals e to the rt is a solution to y double prime minus 5y prime plus 6y equals 0. So once again, this is the function we want to plug in, and this is the differential equation, and we want to figure out for which r this is actually a solution. So this is a very nice exercise of plugging things in. So let's see. Let's put e to the rt on the left-hand side. So e to the rt double prime minus 5e to the rt prime plus 6e to the rt. And again, let's see if that equals 0. Now, if you differentiate e to the rt once, that gives you 5r e to the rt by the chain rule. If you do it twice, it's r times e to the rt. So r squared e to the rt. And then plus 6 e to the rt. That is 0. Now notice there is this common factor of e to the rt. So let's factor this out. So we get e to the rt times r squared minus 5r plus 6 equals 0. Now, we would like to cancel out e to the rt, but remember, we can only do that if it's non-zero, but not a problem, because e to the rt is always positive for all t. And then what we're left with is simply a polynomial equation, r squared minus 5r plus 6 equals 0, which then we can factor out as r minus 2. That's r minus 3 equals 0. So r equals 2 or 3. So what this tells us is, well, e to the 2t solves this and e to the 3t. Because that's for r equals 2. And e to the 3.